Hey everyone, and welcome to this video on how you can use Vyper to build smart contracts. In this video, we'll be going over creating and deploying a Vyper smart contract onto the XDC blockchain network. So what will we be covering in this video? The first thing we'll be going over is what exactly is Vyper to begin with. A lot of people may not have heard about Vyper, so we'll go through that first. Then we will talk about the difference between Vyper and Solidity. And finally, we'll run a quick demo of building and deploying a Vyper smart contract onto the XDC network. So what exactly is Vyper to begin with? Vyper is simply a smart contract development language. It's a smart contract development language which was developed in 2018 and it was created as an alternative to Solidity. And the way it majorly differs is the way its syntax is written and the complexity which it uses. So the reason we call it a more secure alternative to Solidity is because it eliminates many of the complex features of Solidity, such as function overloading and recursive calling. These are functions which are for more advanced use cases, but often if used incorrectly, they are the ones which end up creating loopholes and bugs that hackers can exploit to steal money from smart contracts. Often when we see hacks which have occurred publicly for various DeFi projects or various smart contracts which are deployed onto a Solidity based smart contract chain, oftentimes it is using these well-known exploits in the programming language that hackers are able to get control of that particular smart contract. The second thing is it enforces more stricter rules around variable types and arithmetic operations. A very simple example of this is if you want to divide something by 0, you would need to have the right kinds of bounds in place and checks and balances in place to make sure that somebody isn't trying to divide by 0 within a smart contract. Because if you don't check for that, then it'll try to return a non-number value or a garbage value or an infinite value. And that might cause some of the mathematics which that operation relies on in the smart contract to not work properly. So enforcing strict rules around the types of variables there are, making sure that if the number which is being used is a 8-bit long integer, then it's not being stored in a 4-bit integer, things like that, or the arithmetic operations like division especially, or exponentiation. These things are more strictly handled in Vyper than they are in Solidity. Now, Solidity does have some workarounds for these things, like there are ways to install packages like you would do for JavaScript or something like that, which may be able to deal with this, but native support for these things is available majorly in Vyper. Finally, Vyper is not as widely used as Solidity, but it is gaining a lot of popularity because it is a smart contract scripting language which was developed in 2018, whereas Solidity has been around for much longer. So that's why it hasn't gained as much popularity. So let's look at the key differences between Vyper and Solidity. Let's go one by one and I'll explain each difference. When we say language type and Python based, what I mean by that is the syntax is very similar to Python as opposed to any other language. And similarly, Solidity's syntax is very similar to C++. That is one major difference. So if you're someone who is more developed, like who has developed a lot of Python apps in the past or has experience in developing Python based applications, maybe Flask or something like that, then shifting from that to Vyper will be much easier for you. Whereas if you're a person who's worked more in the system side of things and has used a lot of C++ in the past, then maybe Solidity is an easier fit because you've written something like this in the past. The second thing is syntax. Now this is a more subjective opinion, but Vyper, because it is based on Python, has a more cleaner and straightforward syntax. You can easily read what that function is trying to do just by seeing the code. Whereas Solidity, owing to being more C++ based, has more verbose and complex syntax. Another thing about Vyper is it is more focused on security. And that is what we talked about previously, where it has strict typing, fewer features, things like recursive calling and things like that are subdued in Vyper, because that can eventually end up to security loopholes, which may cause problems. Whereas Solidity is an open box. You can do anything you want with it pretty much. It has a lot of features, it has a lot of flexibility, but that comes at a trade-off for security. So if you know exactly what you're doing, then Solidity is the right fit for you if you want to use more advanced use cases. Whereas if you're dealing with less advanced use cases, Vyper is a better initial starting point to check if your smart contract is working or not. Another thing about Vyper is because it's more Python based, it's slower and less efficient. That's because Python inherently is less fast and less efficient than C++, which is what Solidity is based on. Vyper, also being more readable because it's Python based, is easier to debug, whereas the Solidity syntax being more complex makes it more difficult to debug. Then about libraries. Now, libraries are simply ways to add functionality into your code because of what we call being able to inherit different features from other people. So if somebody creates a function and publishes that as a library, then you can sort of import that functionality into your code. And because Vyper has not been around for as long as Solidity has, the libraries are less available in Vyper for trying out different things, whereas a wider range of libraries are available for Solidity. In terms of adoption, because again, it has been introduced to the world at a much later time, the adoption of Vyper has not been as widespread as Solidity's has been. And because of that, you may see that the support which you might get, the community support, as is in the second last point, will be a bit less for Vyper than you get for Solidity, because they're just simply more developers who are using Solidity. So there are a higher chance that there will be more people who run into the same problems you have faced in the past. The learning curve is much easier for Python, therefore is also much easier for Vyper. Whereas for Solidity, because it's more C++ based, especially for people who haven't done C++ in the past, it is a more steep learning curve. Finally, EVM compatibility means if you write a smart contract in Vyper or Solidity, will it work natively on any Ethereum based chain? So that can be XDC, that can be Ethereum itself, that can be many popular chains right now, which are all EVM compatible. And Vyper and Solidity both are EVM compatible, which means that if you were to write the same smart contract in both Vyper and Solidity, and if you were to deploy both of them onto the same chain, then they will work the exact same way. So going with either of them is a matter of personal preference. It's not a matter of whether you will get a better experience in one or the other. It's just that based on your use case, based on your background, and based on what you want to get out of your smart contract which you're writing, you can make a decision between Vyper and Solidity. Both of them have very good documentation, very extensive documentation. And even though the community might be smaller in Vyper, the significant advantage to having a smaller community is if let's say you're doing a freelancing application and a particular company wants to only use Vyper, they do not want to use Solidity for whatever reasons, then the number of developers, like the developer pool, so to speak, is less for Vyper. So if you know Vyper, then you stand out because that is a more unique skill set. Granted, there might be lesser opportunities, but when those opportunities arise, very few people know or have the requisite skills to be able to grab that contract, so to speak. So I would suggest learning Solidity and Vyper, trying both of them out and seeing which one fits best for you. So without any further ado, let's look at a demo for how you can use Vyper to develop and publish a smart contract onto the XDC blockchain. Okay, everyone. So now let's look at a demo on how you can use Vyper to develop and deploy a simple smart contract onto the XDC network. So in order to do that, open up your browser and type in Remix Ethereum. That will give you a Google search for the Remix IDE, which is an online IDE which you can use to write smart contracts in the browser itself. You don't have to download anything for this. And when you click on the first link, you'll be shown this particular website. Now this is being recorded on the 9th of April 2023. So the UI might change if you see this website in the future. Now that you can see this workspace, the first thing you would want to do to start using Vyper is you can see the Vyper logo right here. You can click on the Vyper logo right here and you can see that the Vyper compiler is up and it's running. So in order to start with some basic starter code which the Vyper team has created, we can click here to clone the Vyper examples repository. Once we click on that, it'll show that it's cloning the Vyper repository. Now it's cloning the Vyper repository right into your browser. So you don't need to do anything apart from just click on that and it will do everything in the backend. Once that's done, it will tell you that the repository has been cloned successfully and the workspace called Vyper has been created. To access that, the first thing you'll do is you'll click on the file explorer and you'll see these workspaces. This workspace is the Vyper Lang workspace. Like if you click on this, you can see all of the workspaces. And the Vyper Lang workspace is the one we want to see because that is the one that has all of the Vyper code we want to use. So if you click on examples, you can see that these are all of the examples which have been created by the Vyper team to just try things out. You can go through all of these at your own pace. For the time being, we'll go through a very simple smart contract to understand how it works in the backend. In order to do that, we'll click on something called storage and storage.vy. Note that .vy is the extension for Vyper code, just like .py is for Python. Now, clicking on this shows you the .vy code, which is the Vyper code, which is the smart contract of itself, which shows you the functionality of what this smart contract will do. So this is a very simple smart contract. All it does is it stores a variable on the blockchain. When you initialize that variable to something, it will set that value to the stored data variable. And the stored data variable is a variable which is contained inside the blockchain, inside that particular smart contract only, and only accessible from there. And there's a setter which has been created, which will set the value based on whoever is calling the smart contract. As simple as that. So in order to deploy the smart contract onto the XDC blockchain, the first thing you'll do is you'll go to the Vyper compiler. Now we'll click on local compiler. So we'll click on remote compiler. Remote compiler is the thing which is used to compile remotely. Local compiler means if you have downloaded a Vyper compiler onto your computer, you would use that. We can use the remote compiler and we click on compile examples /storage.vy, which is this. Once it's done compiling, it will show you the compilation output, which is the ABI, the bytecode, the runtime bytecode, and all of these other things. So once you have this ready, we can see that there's a checkbox next to the Vyper extension, which tells you that the compilation had succeeded. Now it's time to deploy. In order to deploy, what you'll do is you'll click on this button which says deploy and run transactions. Now, in order to see the environment, like you'll see the environment drop down, and in order to see the environment which we want to use, you'll click on this drop down and you can see all of these environments. The one you want to use is called MetaMask. MetaMask is the wallet of choice for most developers, and I've created a video separately on how you can download and install XDC Pay, which is very similar to how MetaMask works. So in order to connect this Remix IDE to the MetaMask extension, all you'll do is you'll click on injected provider and you'll see a notification pop up on the top right corner, which shows you the welcome page, and it'll ask you for your password. So I'll enter that. And once I click that, you'll see that it has connected to my local XDC Pay extension. This is my local XDC Pay extension, and this is just some of the older transactions I've done. This is the XDC I have. If I want to get some test XDC, what I can do is I can copy my account number to the clipboard, go to Google and type in XDC Pay faucet. You can see that this is the faucet for XDC. Enter my account number, authenticate that I'm not a robot, and request for XDC. Once this goes through, the faucet will provide 1000 XDC to my account. So it'll take a sec, and you can see that my balance has now been updated from 999 to 1999. Now that we have some test XDC in order to play around in the XDC sandbox, so to speak, we have the account connected, and this will also update later, which you can see it just did. And now that we have the contract which is compiled, we can say deploy. And inside this text box, we can type in the value we want the integer to be at the very beginning. So let's just call it 60 for the time being. When we say deploy, it's going to ask us to create the contract, and this shows the amount of gas fees, the amount and gas fees we'll need and things like that. When we click on confirm, it'll show that the transaction was being completed, and once that is done, it'll show that the transaction was actually completed. So we can click on the extension and we can see that this was the last transaction which was done, which was a contract deployment. If we click on that, we can view it in block scan. It will take a second to load. We can see that this was the transaction which was created. So this was to the smart contract, which we'll open up here. And there are 9 block confirmations already. So that means after creating our transaction, there have been 9 blocks which have confirmed it already. So our transaction has been properly posted onto the XDC blockchain. We can also see that this is the smart contract which was created and other information about it. So now that we've deployed it, we can see our deployed contracts and we can see the stored data. So if we were to call that, it will tell us what the stored value currently is, which is 60. If we want to modify it to, let's say 100, we can do that and we can say set. Once that happens, it will ask us to do this transaction again with this much amount as the amount of transaction fees we'll have to pay. Once we click on confirm, it will say that the transaction is pending, then the transaction has been completed. And when we go to transactions here, we can refresh the smart contract. And we can now see, we can go to the XDC Pay tab and we can see that this is a contract interaction. So if we click on that, it shows that the transaction was completed. Again, it already has 10 block confirmations, which means the transaction has also been confirmed. Now, if we were to call the stored data function, it will show that the new variable has 100 as the value. This means that the contract has been successfully deployed onto the XDC network, and you can perform all kinds of things you want, like all kinds of trial and error, all kinds of functions, all kinds of tests to make sure that the functionality is as you expected. Once that is completed, then you can convert this into a final smart contract and push it onto the main chain. So this was just an overview of how Vyper can be used to deploy smart contracts onto the XDC network. I hope you enjoyed this video and learned something from it. If you guys have any questions, feel free to post them in the comment section below and I'll be happy to answer them. Until then, stay safe, take care, and I hope you guys have a great day. Thank you.